Today, two topics. In topic one, I want to show you more examples about using the term formulas in these three sections to compute derivatives. The second topic is higher derivatives. Now, topic one. Example one. Let y be this function. Find an equation of the line tangent to the graph of the function at the point x is 1. To help myself answer this question, I arbitrarily draw a curve and suppose this curve is the graph of this function. Suppose 1 is here. Corresponding to 1 is this point on the graph of the function. This point, the x coordinate is 1. The y coordinate is function value at 1. To get function value at 1, plug in 1 in the x here, then the function value at 1 is 1. So this point, x coordinate is 1. Y coordinate is also 1. At this point, there is a tangent line. We need to write down the equation of this tangent line. By point slope formula, to write down the equation, we need to determine the slope of this tangent line. To find the slope of the tangent line, we compute the derivative of the function, because derivative is the slope of a tangent line. Take derivative on the function. Move the constant 2 outside the derivative. Then we have this equation. The function under the derivative seems to be a product, but actually it is a quotient because the power is negative. To compute the derivative of this quotient, we apply quotient rule. Then we have this equation. Next, apply the difference rule here. Then we have this equation. Move the constant 3 outside this derivative. Then we have this equation. Now, derivative on x squared by the formula for power function, it is 2x. X derivative is 1. 1 constant derivative is 0. Then we have this equation. Now, distribute 2x to 3x and to 1. Then we get the first two terms. And then x squared times 3 times 1 minus 0 is 3x squared. Combine the first term and the third term, then we get this equation. This is the derivative of the function. Also, it is the slope of the tangent line at the point, at the general point x. After we compute the derivative of the function, we plug in 1 in x, to get the slope of the tangent line at the point 1. The slope of the tangent line at the point 1 is 1/2. Now, About this tangent line, we have slope. Slope is 1/2. And also we have this point on the tangent line. This point is 1. Function value at 1. Function value at 1 is 1. So below this point, below the slope, we can write down the equation of the tangent line by point slope formula. By this formula, the equation of the tangent line at the point 1 is y minus y1 is equal to slope parenthesis x minus x1. Function value at 1 is 1. Simplify this equation, then this is the equation of the tangent line at 1. Example 2. Find an equation of the tangent line to the curve of this function that is parallel to this line. About this line, if we move -3x and -1 to the right side, then we see that the slope of the line is +3. To help myself to answer the question, now I arbitrarily draw a curve, and suppose this curve is the graph of this function. And draw a line, and suppose this line is the given line. This line, the slope is 3. On the curve, somewhere on the curve, the tangent line there is parallel to this given line. Now we need to write down the equation of this tangent line. Because the tangent line is parallel to the given line, and the given line, the slope is 3. So the slope of the tangent line is 3. By point slope formula, to write down the equation of this tangent line, we need to determine the point. What is the x coordinate and the y coordinate of this point? To find this point, compute the derivative of the given function. The given function x times square root of x in power is x to 3/2. Derivative of x to 3/2 is 3/2 times x to 1/2 by this formula. This is the derivative of the given function, and also it is the slope of the tangent line to the graph of the given function at the general point x. Now set derivative equal to 3 and solve this equation. Move 3/2 to the right side, then we have this equation. Take square on the both sides, then x is 4. So this point, the x coordinate is 4. The y coordinate is function value at 4. Now about this tangent line, we know one point and also the slope of the tangent line. So by point slope formula, we can write down the equation of this line. The equation is y minus y1. Y1 is function value at 4. Is equal to slope number 3, parenthesis x minus x1. x1 is 4. Function value at 4. Plug in 4 in the function. Then 4 times square root of 4. It is 8. Function value at 4 is 8. Simplify this equation. Then this is the equation of the tangent line to the graph of this function that is parallel to this given line. Example 3. Differentiate the following functions. Differentiate means compute derivative. Part A. Take derivative on this function. This function is a sum of two functions. So summation rule. Then we have this equation. For this derivative, the function is a product. The function x squared times the function psi. So we apply product rule to this derivative to get this equation. Now, derivative of cosine is negative sign. Derivative of x squared is 2x by this formula, the formula for power function. Derivative of sine is cosine. Therefore, this is the derivative of the function in part A. Part B. The function in part B is a product of three functions. Function x times function ex times function psi of x. To compute the derivative of this function, we need to apply product rule twice. First, we grouped the first two functions together. Then the function becomes a product of two functions. This function times function psi of x. Now apply product rule. Then we get this equation. To compute this derivative, because the function is a product, function x times function ex. So apply the product rule to this derivative. Then we get this equation. Now, derivative of x is 1. Derivative of ex is ex. Derivative of sine is cosine. Simplify this result a little bit, then this is the derivative of the function in part B. Part C. The function in part C is a product of three functions. Function x times function lateral log of x times cosecant x. So to compute the derivative of this function, we need to apply the product rule twice. This is one solution. A second solution is we can write cosecant as 1 over sine. Then the function becomes a quotient. The solution is here. Write cosecant as 1 over sine. Then the function is a quotient. Take derivative on this quotient by quotient formula. We have this equation. Now, in this expression, we need to compute this derivative and this derivative. For this derivative, we apply product rule. Then we have this equation. Now, derivative of x is 1. Derivative of lateral log is 1 over x. Derivative of sine is cosine. Simplify this result, then we get this equation. This is the derivative of the function in part C. Example 4, each of the limits is the derivative of some function f at some point a. Find a possible function f and upon a. Then evaluate the limit by computing the derivative of the function at the point a. To answer the questions, we need to recall the definition of derivative. The definition of derivative says that a derivative is a limit. Now, part A. Compare the given limit with this formula. This is the given limit. This is the formula. Compare these two equations, then we can see that A is 1. A is 1. Function f is x to 1000. F of A is 1. Therefore, the answer to part A is the function is x to 1000. The point A is 1. So this limit is equal to derivative of the function at 1. That means that take derivative on the function, then plug in 1 in x. By the power formula, x to 1000 derivative is 1000 times 9, x to 999. This is the derivative of the function at x. Now plug in 1 in x, then we get derivative of the function at 1. It is 1000. Therefore, this limit is 1000. Part B. The given limit is the derivative of some function f at some point a. To find the function f and the point a, this time I compare the given limit with the second formula. This is the given limit, and this is the second formula. Compare these two limits, we can see that f of a plus h is the square root of 9 plus h. F of a is the square root of 9. So we have these two equations. The left-hand side of this equation is a plus h, and the right side is 9 plus h. Therefore, a is 9. And this equation is f of 9 plus h is equal to square root of 9 plus h. Now, below 9 plus h by x, then we have f of x is equal to square root of x. So we conclude that the function f in part B is square root of x, and the point A is 9. Therefore, the given limit is derivative of the function at the point 9. To compute this derivative, take derivative on square root of x. This is function f of x. Then plug in 9 in x. Derivative of square root of x is 1 over 2 times square root of x. The detail is here. Now plug in 9 in x, then we get the limit is 1 over 6. Now we turn to topic 2, higher derivatives. Given a function f, take derivative on it, then we have f prime of x. Since f prime of x itself is a function, we can take derivative on it, and the notation is f double prime of x. F double prime is called the second derivative of the function f. Similarly, f double prime of x is a function. We can take derivative on it, and the notation is f triple prime. F triple prime is called the third derivative of the original function f. In general, we can take derivative n times on a function, and the notation is this. Because y is equal to f of x, this notation is equal to this notation. In particular, when n is 1, this notation is f prime of x. When n is 2, the notation is f double prime. When n is 3, the notation is f triple prime, and so on. Recall that there are two popular notations for derivatives. One is the prime notation. The second one is the d over dx notation. Now, let's see how to represent higher derivatives in terms of the d over dx notation. Take derivative on the function. The d over dx notation is this. Take derivative again. Replace this prime by d over dx. Then replace f prime of x by this. Then we have this equation. D times d is d squared. Dx times dx is dx squared. This is the notation for second derivative. Take derivative on the second derivative. Replace this prime by d over dx. And replace f double prime by this. Then we have this equation. D times d squared is d to the third. Dx times dx squared is dx to the third. This is the notation for the third derivative. Take derivative on the third derivative. Replace this pi by d over dx. And replace f triple pi by this. Then we have this equation. D times d to the third is d to the fourth. Dx times dx to the third is dx to the fourth. This notation is for the fourth derivative. In general, take derivative n times on the function f. The notation in terms of d over dx is this. Example 1, under the second topic. Let f be this function. Find the second derivative of the function at the point 1. To find the second derivative at the point 1, first compute the second derivative at the point x. All the 10 formulas are about derivative at the point x. After we get the second derivative at the point x, then plug in 1 in x to get the second derivative at the point 1. Take derivative on the function f. Function f is a quotient, so we apply the quotient rule to this derivative, and we have this equation. Apply summation rule here, then we have this equation. Derivative of x squared is 2x. Derivative of 1 is 0. And derivative of x is 1. This is the result of derivative of function f. Because we need to take derivative again, it is good to simplify this result so that our following computation is easier. Distribute 2x to 1 and to x, then we have this equation. Cancel 1 x squared, then we have this equation. This is the simplified result of derivative of function f. Now, take derivative again and apply the quotient rule to this derivative. Then we have this equation. Expand 1 plus x squared, then we have this equation. Apply the summation rule here and here, then we have this equation. Move out the constant tool, then we have this equation. Derivative of x is 1. Derivative of x squared is 2x. Derivative of 1 is 0. And derivative of x is 1. And this is 2x. Then we have this equation. Simplify this expression a little bit, then this is the result of the second derivative of function f. Now, to find second derivative at the point 1, plug in 1 in x. Plug in 1 in x, then we get the second derivative at the point 1 is 1/4. Example 2, if function f is the function x times ex, find the nth derivative by calculating the first few derivatives and observing the pattern that occurs. Take derivative on the function f. The function is a product, so by product rule, we have this equation. Derivative of x is 1, and derivative of ex is ex. So this is the result of the first derivative. Take derivative again. By summation rule, we have this equation. Derivative of ex is ex. Derivative of x times ex. From here, it is ex plus x times ex. Now, ex plus ex is 2 times ex. This is the result of the second derivative. Take derivative again. By summation rule, we have this equation. Move out the constant 2. We then have this equation. Derivative of ex is ex. Derivative of x times ex. From here, it is ex plus x times ex. Combine 2 ex and ex, then this is the result of the third derivative. Similarly, to compute the fourth derivative, the result is 4ex plus xex. Now, from the first 4 derivative that we have computed, we can observe a pattern. The first derivative is ex plus xex. The second derivative is 2ex plus xex. The third derivative is 3ex plus xex. The fourth derivative is 4ex plus xex. So we conclude that the nth derivative is nex plus xex.